Welcome to the Explainer. Today, we're going to tackle one of the most critical parts of any real-world Kubernetes setup, services. If you've ever wondered how your apps stay up and running inside a cluster that's constantly changing, well, this is the Explainer for you.
Okay, so let's just dive right in. To really get why services are such a big deal, you first have to understand the huge problem they were built to solve. And honestly, it all comes down to the way pods work.
Just imagine this for a second. You're trying to use an app, but its network address just keeps changing, constantly. One minute it's there, the next, poof, it's gone, and has a new address you don't even know. It would be total chaos, right? In production, that chaos means downtime, and it means users can't reach your application. Well, that is exactly the situation we'd have in Kubernetes without services.
And here's the kicker. This isn't a bug, it's a feature. Kubernetes is designed from the ground up to be self-healing. So when a pod crashes, the system is smart enough to automatically spin up a new one to replace it. This is great for making our apps resilient, but it creates a massive networking headache.
This slide really just nails the problem. So the application is technically healed, right? We have a new pod up and running. But look, its IP address is completely different. Anyone or any other application that was talking to that old IP is now just shouting into the void. So even though Kubernetes fixed the pod, the connection is broken. From a user's point of view, your app is down. And you're probably thinking, okay, can't we just update the IP address? In any real production cluster, just forget about it. It is literally impossible. We're talking about hundreds, maybe thousands of pods that are restarting and scaling all the time. Trying to keep track of all those IPs by hand, it's a recipe for disaster and just constant, painful downtime. So if we can't rely on these temporary pod IP addresses, how does Kubernetes give us a stable, trustworthy way to access our applications? The answer is this really elegant idea called a service. And this is the solution, right here in a nutshell. Instead of connecting directly to a pod, which is unstable and unreliable, we connect to a service. The service acts like a permanent, fixed front door for our app that never, ever changes, even as all the pods are scrambling around behind it. So the most important thing to get is that a service provides us a stable address we can actually count on. It completely separates the identity of our application from the temporary network locations of its pods. This idea is a huge part of site reliability engineering, building systems that are self-healing and reliable by design. Okay, so this brings up a pretty big question, right? If a service isn't tracking those specific changing IP addresses, how in the world does it know which pods to send traffic to? Well, the magic is in a simple but incredibly powerful system for discovery. So instead of chasing after these fragile IP addresses, Kubernetes uses something much smarter: labels. These are just simple little key value tags that we stick on our pods. A label like app payment gives all the pods for our payment application a single shared identity that never changes. And this just shows you how brilliantly dynamic the whole thing is. We create a service and we tell it, hey, I want you to look for any pods with the app payment label. And that's it. The service then just constantly scans the cluster, automatically building and updating its list of healthy pods that match that label. It's all completely automatic.
And as if that wasn't enough, Kubernetes makes it even simpler. Every single service gets its own stable, built-in DNS name inside the cluster. So now, other apps don't even need to know the service's IP. They can just use a nice, human-readable name like payment.default.svc, and that name is the one thing that will never change.
All right, so we've got this stable address for our app inside the cluster. That's great. But what about the outside world? How do we control who can access it? What if we need to open it up to our internal teams or, the whole internet? Well, this is where service types come in. Kubernetes gives you a few different flavors depending on what you need. Cluster IP is the default, and it keeps things locked down inside the cluster, perfect for backend services talking to each other. Node port is useful for internal tools. And then there's load balancer, which is for when you're ready to go public.
Now, this load balancer type is really cool. When you use it on a cloud platform like AWS, Azure, or Google Cloud, Kubernetes actually talks directly to the cloud's API. It tells the cloud provider to automatically create a real external load balancer and wire it up to your service. And just like that, your app gets a public IP address and is available to the whole world.
Okay, let's bring all this home. We understand all the different pieces now. So what does it actually take to make sure our services are configured right and are truly ready for production? This shows you the whole journey. A user connects to that stable service address. Then, a component called kubeproxy, which runs on every single machine in your cluster, grabs that request. It then intelligently load balances it to one of the healthy pods in the back, making sure everything stays available and balanced.
Now you have to pay attention here, because getting this stuff right is absolutely crucial. As you see on the slide, you should never hard-code a pod IP. Ever. But just as important, you have to make sure your pod's labels perfectly match your services selector. A tiny typo here won't give you an error, but it will cause a silent, complete outage. It is the #1 thing to check when your app suddenly isn't reachable. So if you only take one thing away from this whole explainer, let it be this. Pods are temporary. Their IP addresses will always change. But services provide the stability. They are the anchor that makes production workloads on Kubernetes possible. If you really understand services, you understand a core piece of what makes Kubernetes so powerful.